Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
Mitsubishi can be called a pioneer on the way of mass introduction of direct fuel injection system. Unlike Mercedes, which long before Mitsubishi made attempts to implement direct injection on cars, simply applying developments from experience in aircraft construction. Mitsubishi engineers created a system that would be convenient and suitable for everyday use of the car. Let's consider the GDI engine, the device and the principle of operation of the power system. Basic concepts. In the article about the principle of operation of the injector power system, we learned that there are several types of fuel injection systems: single-point injection, mono-injector, distributed valve injection, full injector, distributed injection into the cylinders, direct injection. Gasoline direct injection, which means gasoline direct injection, immediately tells us that GDI engines have internal mixing. In other words, fuel is injected directly into the cylinders. But what exactly are the advantages of direct injection? Reduced temperature in the combustion chamber, as fuel can be supplied in the liquid phase directly at the end of the compression stroke. This feature reduces the risk of detonation. This makes it possible to obtain greater efficiency from compression of the fuel-air mixture, FAM, and to adjust the ignition advance angle over a wider range. It is possible to adjust the composition of the fuel-air mixture, which makes it possible to utilize the combustion energy of the fuel-air mixture more efficiently at different engine operating modes. The problem of low efficiency of gasoline engine, compared to diesel, is in the small limits of adjustment of the composition of TPVS. It has been established theoretically and experimentally that 14.7 kilograms of air is required for complete combustion of 1 kilogram of gasoline. Such a ratio is called stoichiometric. The engine can run on a lean mixture, about 16.5 kilograms of air, 1 kilogram of gasoline. But already at 19.1 TPVS from the spark plug will not ignite. However, even a mixture of 16.51 is considered too lean for normal operation, because the TPVS burns slowly. And this is fraught with loss of power, overheating of piston rings and walls of the combustion chamber. Therefore, the working poor homogeneous mixture is in the range of 15-16:1. Preparing a rich mixture in the cylinders with the ratio of 12:1-12:3:1 and shifting the ignition timing, we get a gain in power. At the same time, the environmental performance of the motor deteriorates significantly. GDI economy. Several factors contribute to this: a special intake manifold design, injectors, which allow not only to accurately dose the amount of fuel supplied, but also to regulate the shape of the torch, a special shape of pistons. But what exactly is the peculiarity of the operating principle that allows GDI engines to be so economical? Due to the special shape of the intake manifold, which consists of two channels, the air flow has a certain direction even at the intake stroke, instead of entering the cylinders chaotically, as in the case of conventional engines. Once in the cylinders and hitting the piston, it continues to swirl, thus contributing to turbulization. The fuel, which is fed in the immediate vicinity of the piston to the TDC by a small plume, strikes the piston and, picked up by the swirling air stream, moves. And at the moment of spark supply is in close proximity to the electrodes of the spark plug. As a result, there is a normal ignition of TPVS in the vicinity of the spark plug. While in the surrounding cavity is a mixture of clean air and exhaust gases fed into the intake by the EGR system. As you understand, it is not possible to implement this method of gas exchange in a conventional engine. Engine operation modes. GDI motors can work effectively in several modes: ultra-lean combustion mode, ultra-poor mixture mode. The principle of its flow has been discussed above. It is used when there is no heavy load on the engine. For example, during smooth acceleration or constant maintenance of not too high speed. Two-stage mixing, an enriched mixture mode with an air-fuel ratio close to 12:1. It is used at sharp accelerations, high engine load. This mode is also called open-loop mode, when the lambda probe is not interrogated. In this mode, fuel correction for the settlement of harmful emissions is not carried out. After all, the main goal is to get the maximum output from the engine. The Electronic Engine Control Unit, ECU, is responsible for switching modes. It makes a choice based on the readings of sensor equipment, DPDZ, DPKV, DTOJ, lambda probe, etc. Two-stage mixing. Two-stage injection mode is also a feature that allows GDI engines to be extremely fast. As mentioned above, the mixture composition in this mode reaches 12:1. For a conventional engine with distribution injection, such a ratio of fuel to air is too rich, and therefore, such a FIPS will not ignite and burn effectively, significantly worsening the emissions of harmful substances into the atmosphere. The open-loop mode involves two stages of fuel injection, a small portion at the intake stroke. The main purpose is to cool the remaining gases in the cylinder and the walls of the combustion chamber. The composition of the mixture is close to 60:1. Subsequently, it allows more air to enter the cylinders and create favorable conditions for ignition of the main portion of gasoline. There is a great desire to talk about how exactly Mitsubishi engineers tamed turbulence, about laminar and turbulent motion and re-number introduced by O. Reynolds. All this would help to better understand how exactly in GDI motors layer-by-layer mixing is created, but unfortunately, 2 articles are not enough for that. Fuel pump. Like a diesel engine, a high-pressure fuel pump is used to create sufficient pressure in the fuel ramp. Over the years of production, the engines were equipped with several generations of fuel injectors. 7-plunger fuel pump, from the beginning of 1996 to the middle of 1997. The short period of stay on the conveyor is caused by the lack of reliability. Especially it concerns the operation of cars in regions with poor gasoline quality. 3-sectional fuel injector, which already had a significant safety margin. The fuel injector, popularly nicknamed tablet. Refined tablet. Fuel injector, in fact, did not differ from the previous generation, except for the high-pressure regulator removed from the pump housing. Possibility of forming different types of gasoline atomization, maximum maintenance of dosing accuracy regardless of temperature and pressure in the combustion chamber. Particularly noteworthy is the swirl device located in the nozzle body. It is thanks to it that the fuel, flying out of the nozzle, is better picked up by the swirling airflow, which contributes to better mixing of the fuel mixture and redirection of the mixture to the spark plug. Operation. The main troubles associated with the operation of engines with direct injection from Mitsubishi on domestic expanses, where of the TNDV. The pump is a node with pretentious requirements for fitting parts, and the main problem is not in the level of manufacture, but in the quality of domestic fuel. Of course, even now it is possible to run into bad fuel. But the times when the quality of gasoline was a real headache and risk of financial losses for owners of cars with GDI engines, fortunately, have already passed. Direct injection GDI unit. GDI injection system LED. In conclusion, understanding the features of gasoline direct injection, or GDI, engine operation is essential for appreciating the advancements in automotive technology. From improved fuel efficiency and enhanced performance to reduced emissions, GDI engines represent a significant leap forward in engine design. As we continue to innovate and refine these systems, the future of automotive engineering looks promising. Thank you for watching, and we hope you gained valuable insights into how GDI engines operate and their impact on the driving experience.